In this video, we're going to look at finding the limits from a graph. So this first one, we'll call this one the graph of f of x, and we'll call the second graph the graph of g of x. So if we wanted to find the limit as x approaches -1 from the left of f of x, -1 from the left means that we're looking at, here's our point -1 right here. Our graph actually is two different pieces. What we're going to do is if we're approaching it from the left or from the negative side, we're going to look at our graph as we're coming to the left of that point. So just kind of travel along your graph there. What is happening to the y value? As we get closer and closer to the x value of -1, our y value is getting closer and closer to a y value of -2. If we take the limit as x approaches -1 from the positive or from the right side of our function f of x, we're looking at if we are always on the right or we're always bigger than -1, then that means that the part of the graph we're looking at is going to be up here, and as we get closer to -1, our y value is getting closer to a y value there of +1. The limit as x approaches -1 in general, so we don't have anything at the top, we're looking at these two numbers. It does not matter where the solid dot is, it does not matter what's happening at the graph at that point. The only thing we're interested in is what's happening on the left and what's happening on the right. And since these two numbers are different, then our limit does not exist because it's approaching two different values. All right, let's use this same function and look at the limit as x is approaching -3 for our f of x. As x is approaching -3, it doesn't matter we're coming from the left or from the right, both of those values are approaching a y value of 1. And since it's approaching it from the same y value from both directions, it doesn't matter that that's an open circle. Limits do not involve anything what's happening exactly at that point. It's just as you're getting closer and closer, what is happening to the y value. So if we are looking at values that are very close to -3, coming from the left and coming from the right, it's getting closer and closer to a y value of that +1 there. All right, now let's look at the limit as x approaches 1 for our g of x. So now we're looking at this graph here on the bottom. X = 1 is right here. And so the point that we're looking at is as we get closer and closer there. This is another one as we approach from the left and from the right. It doesn't matter whether this is an open circle like we saw on the last example, whether it's a closed circle, or whether it's just a straight line. Our y value is getting closer and closer as we're coming from the left. Our y value is getting closer and closer to a y value of 4. As we're getting closer and closer on the right, our y value is also approaching 4, and so the limit as x approaches 1 of g of x is 4. Now, here's another one that's split. This one different from our first example in only the case that it doesn't have a closed circle on either end, but like I said a while ago, it does not matter what's happening actually at that point. The limit as x approaches, in this case 3, from the negative side. If we're approaching from the negative side, we're getting closer and closer to this y value here of 3. And if we are approaching from the positive side, our y value is getting closer and closer to -1. And since these are different, that means that the limit as x approaches 3 in general for our g of x does not exist. All right, hopefully this helps you out. I'll see you guys next time.